All right, let's see here. Lesson 34. Lesson number 34. Okay, up until this point, are the distance problems that we've done. So if we have, we'll say the distance of Amelia, right? Amelia is going this way. And then the distance of Destiny, right? So Amelia and Destiny are going the same direction. They have the same starting point, the same ending point. So these distances equal each other. So Amelia's distance and Destiny's distance equal. All right. We could have also said that Amelia's going one way and Destiny's leaving and going the opposite direction, right? But their distance is still equal. Okay, so here Amelia's distance still equals Destiny's distance. And then the second type of problems that we dealt with, where if we had Briar, right, Briar's leaving, so the distance of Briar, and then we could have said that then Carter is going a direction. So we could have said that the distance of Briar plus the distance of Carter equals some value, right? That'd be the same thing as if Briar and Carter were at the same place, they were at the same starting point, and Briar was going one direction and Carter was going the other direction. We could still say that the distance of Briar plus the distance of Carter equal the value, right? And that value being this distance here. All right, so here my distances are the same, they equal each other. Here my distance of Briar plus my distance of Carter equals the value. And the same thing if they're going in opposite directions, or how far apart are they. Now, the distance traveled by one object exceeds by a specific amount the distance traveled by another object. So what I'm going to be doing now are problems that look like this. All right, so if we have, here we have Gage, right? There's the distance of Gage going someplace, right? But then we have the distance, of Caden going here. So Caden is exceeding Gage, but by how much, right? So now we're going to be solving for this value, right? We have to figure out what does Gage need to do to catch up to Caden, all right? Or it could look like this. Let me get back to the block, right? All right, so here we have Caden, but Gage is starting here. So I'm going to be solving for this, right? So how far, what's the difference between the two? What I can say with these equations, let me get to the blue here, I want it thicker, is that I can say that the distance of Gage plus this unknown quantity is going to equal the distance of Caden. And for these equations, I can say that this unknown value plus the distance of Gage is going to equal the distance of Caden. All right, so this is how we're going to be solving them. These problems, where we're finding that missing piece. So here's our first example problem. It says Millicent, they always use such weird names. Millicent began the journey at 6 a.m. at 50 kilometers per hour. Oh, I can't spell. Kilometers per hour. Beauregard, I don't even know what that means. I don't even think I'm spelling it right. Beauregard began to chase her. At 60 kilometers per hour. What time was it when Beauregard, I'm probably not saying that right, but whatever, when Beauregard got within 40 kilometers of her? Got within 40 kilometers of her. Okay, so what do we know? We know that Beauregard and Millicent began at the same point, okay? So I know that they both have the same starting point, okay? So there's Millicent, there's Beauregard. They both have the same starting point. I also know that Millicent traveled 40 kilometers farther. Okay, so I can make this line and I know that she went 40 kilometers farther. I should probably have written this down here. Right? Because she went 40 kilometers farther than Beauregard. So what I can say now is that the distance of Millicent equals the distance of Beauregard plus 40 kilometers. All right? So, and I know that rate times time. Okay, so I'm going to set that up. And I'm going to fill in what I know. The rate of Millicent was 50 kilometers per hour. And the rate of Beauregard was 60 kilometers per hour. And I know that Millicent's time is 4 hours more than Beauregard's time, right? Because she left at 6 a.m., he didn't leave till 10. So her time is TB plus 4. Oh boy. Plus this 40 kilometers, okay? So let me move this here. So now I'm going to distribute. I'm going to take this and distribute. So I'm going to have 50, sorry about the baby, I'm going to get her in a second. 50 TB plus 200 equals 60 TB plus 40. And I'm going to have to erase something so I have more room to finish. Oh my gosh, that's not the eraser. Lily, I'm okay. Okay, so I'm going to rewrite my equation. All right, there's my great wall of an equal sign. I'm going to subtract my smaller variable. So I have 200 equals 10 TB plus 40. Subtract the 40. And I have 160 equals 10 TB. All this stuff in my way. Divide both sides by 10. So 16 equals the time of Beauregard, right? So in 16 hours, Beauregard got within 40 kilometers of Millicent. So 16 hours after 10 a.m. would be 2 o'clock the next morning. And we're going to try and do the next example live because Lily is going berserk.